indeterminate forms. Indeterminate forms. L'Hopital rule. L'Hopital rule. LHO. L'Hopital rule. L'Hopital rule. Concepts. Concepts. First, indeterminate form. What is indeterminate form? What is indeterminate form? The expression obtained with the expression obtained the expression obtained after the substitution after the substitution after the substitution after the substitution does not give enough information to does not give enough information enough information so so to determine the limit to determine the limit determine the limit determine the limit determine the limit means original limit is called indeterminate form. It's called indeterminate 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 forms. Example 0 by 0 0 by 0, 0 by 0, comma, infinity by infinity, infinity by infinity, 0 into infinity, or infinity plus or minus, infinity plus or minus, infinity, infinity power degree, 1 power infinity, etc. These are all called indeterminate forms. These are called indeterminate forms. Indeterminate forms. So if limit, let f of x and g of x let f of x, comma, g of x, f of x, let f of x, comma, g of x, let f of x, g of x be two real valued functions. Hello? Be two real valued functions. Real valued functions. Be real valued functions. Be real valued functions. Defined over a proper domain. Defined over proper domain. Proper domain. Proper domain. Proper domain. Proper domain. Proper domain. So if limit extends to a, f of x equal to 0 and limit extends to a, g of x equal to 0 equal to 0. Then limit extends to a f of x divided by g of x, that equal to 0 by 0. This is called indeterminate form. Indeterminate 0 by 0 form is indeterminate net form. Indeterminate form. So based upon this, L'Hopital rule is there. Theory is 10 marks question. 10 marks theorem. L'Hopital rule proof is 10 marks theory. 10 marks question. L'Hopital rule. The theorem.
అలా కాదు దానికి ఇంకో రాష్ట్రం తీసుకున్న దానికి కూడా చేస్తే
Theorem. Please all the students put mute. If limit extends to a f of x to a f of x, that equal to extension. All of you students will please put the mute. Limit extends to a g of x. G of x equal to 0 equal to 0 and f dash a
మా చెల్లిరా నువ్వు
and f dash a comma g dash of a, f dash of a and g dash of a is not equal to 0. Then limit extends to a, f of x whole divided by limit extends to a g of x, that equal to limit extends to a f dash of x f dash of x divided by limit extends to a g dash of x, g dash of x. Hence we'll see proof of the theorem. 10 marks in theory. Let f of x and g of x be functions. G of x be functions. Be functions of x which cannot be of x which cannot be This can be expanded in expanded in the deleted neighborhood. In the deleted deleted neighborhood. NBD means neighborhood. Deleted neighborhood of x equal to a. Of x equal to a. X equal to a. By Taylor's theorem. By Taylor's theorem. Taylor's theorem. Taylor's theorem. Let f of a equal to g of a equal to 0. Let f of a equal to g of a. Let f of a equal to g of a equal to 0. We know that f of x. We know that WKT means we know that f of x equal to f of a plus of a plus x minus a. X minus a. X minus a. So that equal f of a plus f of a plus f of x minus a f of x minus a f of x minus a into f dash a plus x minus a whole square divided by 2 factorial. X minus a whole square divided by 2 factorial. 2 factorial into f double dash a plus so on R1. R1 is the remainder, nothing but where here R1 equal to R1 x minus a whole power n. X minus a whole power n whole divided by n factorial into f n a plus theta 1 a plus theta 1 x minus a theta is lies between 0 to 1 where theta 1 is lies between 0 to 0 less than theta 1 less than 1. That means so g of x. So g of x equal to that equal to g of a plus x minus a G of into x minus a, g dash of a, g dash of a plus x minus a, x minus a whole square divided by 2 factorial. 2 factorial. G double dash a, g double dash a plus so plus R2 plus R2, where R2 is, go next page, where R2, where R2, where R2, where R2, where R2 equal to x minus a whole power n, x minus a whole power n, all divided by n factorial, c power n into a plus b plus theta 2 x minus a, theta 2 x minus a. That means theta 2 values lies between 0 to 1. 0 less than theta 2 or less than 1. Theta 2 less than 1. So limit extends to a. Limit extends to a. F of x divided by limit extends to a g of x.
సార్ డిస్ప్లే అవ్వట్లేదు.
So limit extends to a f of a plus f of a plus x minus a, x minus a, f dash a plus so on plus r1 all divided by limit extends to a, limit extends to a g of a, g of a plus x minus a, x minus a, g dash of a plus so on plus r2 plus r2. Limit extends to a, limit extends to a, limit extends to a, limit extends to a. Limit extends to a, Okay. Limit extends to a. Limit extends x minus a f dash a. X minus a f dash a f dash a plus x minus a whole square divided by 2 factorial divided by 2 factorial into f double dash a f double dash a plus so on whole divided by r1 whole divided by x minus a g dash of a x minus a x minus a g dash of a g dash of a x minus a g dash of a plus x minus a whole square whole divided by 2 factorial f double dash a plus so on plus r2 plus r2 dividing numerator and denominator of the fraction by common factor. Divide numerator and NR means numerator, DR means denominator by x minus a by x minus a x minus a. So limit extends to a f of x divided by limit extends to a f of x divided by limit extends to a g of x extends to a g of x. So that is limit limit extends to a that equal to limit extends to a extends to a f dash a by plus x minus a whole square divided by 2 factorial into f double dash a plus so on r1 plus r1 divided by x minus a whole divided by g dash of a plus x minus a whole square x minus a whole square divided by 2 factorial x minus a not whole square by g double dash a plus so on plus r2 whole divided by r2 whole square x minus a whole divided by x minus a. So all the terms having x minus a are the since
బాధ అది అర్థమవుతుంది మనకి ఇందాక ఎలా వచ్చింది
all the terms what we did, the numerator and denominator divided by x minus a. We got this result. All the terms having x minus a as a factor vanish. Vanish means to become zero. Vanishes when x tends to a. When x tends to a. So hence the theorem. Hence proved. So corollary of this theorem. Corollary means sub-theorem. Corollary.
Hello, sir.
Corollary.
Hello, sir. సార్
Corollary.
ఒక థీరం చెప్పారు దాన్ని బేస్ చేసుకొని ఒక క్వశ్చన్ సాల్వ్ చేయండి సార్ మాకు ఈజీగా అర్థం అవుతుంది ఇప్పుడు ఈ థియరీ బేస్ చేసుకొని క్వశ్చన్స్ హలో
So corollary is if f dash a and g dash of a are both zero. Both zero. We can prove similarly. Limit extends to a. F of x divided by g of x. That equal to limit extends to a. F dash x by g dash of x. Limit extends to a. F double dash of x. F double dash of x divided by g double dash of x. G double dash of x. So on. Once proved. So using L'Hospital rule, we will do one problem. Example problem. Evaluate limit extends to 0.
Eight.
Evaluate. Evaluate. Yeah. Evaluate. Limit x tends to 0. X e power x. X e power x minus log of 1 plus x. Log of 1 plus x. Log of 1 plus log of 1 plus whole divided by x square. Suppose like that is given question. We need to substitute first x tends to 0. In place of in the numerator and denominator. If you get 0 by 0 form, this is indeterminate form. So we have to use L'Hopital rule. Yes, L'Hopital rule. L'Hopital rule. So L'Hopital rule means how to apply in the numerator separate differentiation, denominator separate differentiation. Limit x tends to 0. Numerator x e power x differentiation. X e power x differentiation is e power x plus e power x into d by dx of x is 1. So minus d by dx of log x is 1 by x means 1 by 1 plus x whole divided by denominator d by dx of x square is 2x. Again you substitute. Again you will get 0 by 0 form means again indeterminate. You have to apply again. Right? Again apply L'Hopital rule. L'Hopital rule. Again apply L'Hopital rule. Again apply L'Hopital rule. L'Hopital rule means again. Next we go next page. Yard page. Again limit. Limit x tends to 0. X e power x. X e power x plus e power x. Minus d by dx of 1 by x minus 1 by x square. So minus get cancelled. Minus into minus plus 1 by 1 plus x 1 by 1 plus x whole square because d by dx of 1 by d by dx of 1 by x is minus 1 by x square whole divided by 2x differentiation is 2. So now substitute. Now substitute in the equation e power x plus e power x. This will become 2 e power x. 2 e power x. Now substitute. Now substitute in place of x 0 means first term becomes 0. Second term 2 into e power 0 is 2. Third term is 1 whole divided by 2. That equal to 3 divided by 2 is the answer. 6 marks question this is. Okay. Next. We solve for check your progress. One more. Next. Second example. Second. So limit. Evaluate limit extends to 0. 1 minus cos. 1 minus cos x whole divided by x square. Whole divided by x square. Solve this by L'Hopital rule. First, substitute in place of x 0, you will get 0 by 0. So apply L'Hopital rule. Apply L'Hopital rule. D by dx of 1. Differentiation, the numerator separate, denominator separate. So limit extends to 0. D by dx of 1 is 0. D by dx of sin x is, d by dx of cos x is minus sin x. So sin x whole divided by d by dx of x square is 2x. Right? That implies 1 by 2 you will take outside. 1 by 2 take outside. Limit extends to 0. Sin x by x. From standard limits, you will get sin x by x is 1. 1 by 2 into 1. That equal to 1 by 2. Right? Next. Next. 4 marks question 1 will do. 4 marks question. Show that 4 marks question. Show that so that limit extends to infinity. Limit extends to infinity. 5 by 2 minus 5 by 2 minus tan inverse x. 5 by 2 minus tan inverse x. Whole power 1 by x. 1 divided by x equal to 1. So solution. Let y equal to limit extends to infinity. 5 by 2 minus tan inverse x whole power 1 by x. So by taking logarithm both sides, apply logs both sides. Apply logs BSE means both sides of the equation. Log y can be written as, so log m power n, we have a formula. Log m to the power of n can be written as n log m, no? N log m. Based upon this law, we can write limit x tends to infinity 1 by x log by x log pi by 2 log pi by 2 minus tan inverse x. Tan inverse x. So, tan inverse x. This x can be written as 1 by x. So, log y equal to limit x tends to infinity log pi by 2 log pi by 2 pi by 2 minus tan inverse x whole divided by x. This is nothing but indeterminate. If you substitute x tends to infinity, you will get, this is infinity, x tends to infinity. You will get infinity divided by infinity, means indeterminate form. Move next page. Indeterminate form. Then apply L'Hopital rule. Apply L'Hopital rule. L'Hopital rule. Apply L'Hopital rule. Apply L'Hopital rule. Then what we'll get? Limit x tends to infinity. Extension. D by dx of log x is 1 by x. 1 by x means 1 by pi by 2 minus tan inverse x into d by dx of d by dx of constant is 0, d by dx of tan inverse x is minus 1 by 1 plus x square. The denominator d by dx of x is 1. Okay. Next. Again, we get 0 by 0 form. We substitute this one. Means so again, limit apply L'Hopital rule again. L'Hopital rule. Limit x tends to infinity. D by dx of tan inverse x is 1 by 1 plus x square. One by 1 plus x square whole square into 2x divided by minus 1 by 1 plus x square. That equal to limit x tends to infinity. X tends to infinity. Minus 2x divided by 1 plus x square. Again, infinity by infinity. Infinity by infinity. Then we'll get. We have to apply again L'Hopital rule. Limit extends to 0. So minus 2 divided by 2x. Minus 2 divided by 2x. 2 by infinity. 2 by infinity is 0. 2 by infinity equal to 0. That means y equal to, what is this? This is our y equal to e power 0, that equal to 1. So log y equal to 0. Here base is there, na? Logarithmic form to convert into exponential form. That equal to y equal to e power 0. That equal to 1. That means what we are observing? Limit, hence limit extends to infinity pi by 2 minus tan inverse x whole power 1 by x equal to 1 is proved. Hence proved. This is for 10 marks question. Here. Hence proved. So what we discussed now? What are the concepts we discussed? Once again, we'll revise. What we discussed first, unit 8. Indeterminate forms and L'Hopital rule. What is indeterminate forms? Indeterminate form. If the expression obtained after the substitution does not give the enough information to determine original limit, that is called indeterminate forms. Indeterminate forms are, what is indeterminate forms are? 0 by 0. Indeterminate forms are what we discussed. Indeterminate form 0 by 0, comma infinity by infinity, comma infinity plus or minus infinity. Next, infinity into infinity, etc. These are called indeterminate forms. They're all called indeterminate forms. So concepts different. Let f of x and g of x be two real valued functions defined over a proper domain. So limit extends to a f of x equal to 0, limit extends to a g of x equal to 0. Then the coefficient limit extends to a f of x divided by limit extends to a g of x, that equal to 0 by 0 form. That is called indeterminate form. For theory, 10 marks. L'Hopital rule. State and prove L'Hopital rule. Statement also you have to learn for there. Here a 10 marks question. If limit extends to a f of x equal to limit extends to a g of x equal to 0, then f dash a and g dash of a, then limit extends to a f of x divided by limit extends to a g of x equal to limit extends to a f dash x divided by limit extends to a g of x. This proof discussed using Taylor's theorem. Right, corollary answer. Next, 1 6 marks sum, 2 6 marks sums we will, and 1 10 marks sum we will prove that. What is that? Show that the limit extends to infinity pi by 2 minus tan inverse x whole power 1 by x equal to 1. Okay, these are all important. We have to read. Okay. Okay. We'll meet next class. Okay. This is easy and important. We discussed 10 marks and 2 problems for 5 marks. Okay. Thank you. I'm leaving. Thank you very much.